Bienvenidos, Ushamdi, and welcome CTS-131, Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Cisco Networking Academy Routing and Switching Essentials version 6 course, and this lab tutorial and solution set is going to be on lab 6.3.3.7. In other words, if you were taking the class in person in a classroom setting and had a rack of equipment, this is going to be the solution set for that lab. And since we're virtual and the course is online, we're going to go ahead and configure everything in Packet Tracer. So not only does this give us another chance to take a look at 802.1q trunk-based Inter-VLAN routing, but it also gives us an opportunity to work with Packet Tracer and to create a topology from scratch. So let's go ahead and dive into Packet Tracer here. And if I come up to the Help menu and I go to About, you can see I'm running Packet Tracer 711.0138. So this is the latest and greatest version of Packet Tracer. And what do we need for this activity? So I'm looking at the Word document that comprises the lab to my left here, and I'll be scrolling through and we'll be building everything out. So we're going to get a 2911 router, right? And once I have all the components here, I'll go ahead and enlarge everything at one time. We're going to need two layer 2 switches. So I'm just going to grab two 2960 switches. And then we're going to need two PCs. And so I'll just grab two generic PCs. All right, and so this is going to be our entire topology. And let me do Control-I to make this a little larger here, and we'll pull these a little bit closer together, so that we're looking at one contiguous image here. Let me roll to the top there. We'll keep it right there. And so here's what we're going to do. We're going to match the topology that's provided for us in the lab. And this is exactly what that topology looks like. Now, let me give us a little more room here. Make things a little more visible. There we go. All right, so this is going to be a good starting point right here. So let's go ahead and start connecting things. So I'll click on the lightning bolt, and that gives me the connections. Everything that we're doing is going to be a simple straight-through connection. So from the PC, I'm going to go from fast Ethernet 0, and into this switch, it's going to be fast Ethernet 06. And then for this PC, which is going to be PCB, I'm going to go from fast Ethernet 0 into fast Ethernet 018. Interesting choice of port numbers. And my guess is Packet Tracer may force us here to use, let me see if a straight through will work, or if they're going to mandate a crossover connection. So we're going to go fast Ethernet 01 to 01. And hopefully this is going to come online. And then finally, we're going to go from fast Ethernet 05 up to the router's gig 01. All right, so just from looking at this, right, it's kind of clear, try to line the PCs up here, it's kind of clear how this is going to work. And so this is going to be PC-A, and this is going to be PC-B. And I'll even put in parentheses VLAN 20, right? And so we should see VLAN 20, and I'll fix this one up here. This is going to be VLAN 10. All right, so it looks like we've got some green lights around the topology here. I'll change that very briefly here just to router 1. Host name will be R1. And there we go. And so switch 1 and switch 2, and so that's actually going to be switch 2. I'll just change it to S2 and S2. So again, we're just doing some housekeeping here on the different components that we're going to be using. Switch 1, and we'll try to make things uniform here. All right, so there is our configuration initially. So let me scroll down here. So we have an addressing table right at the very top, and let's start with router 1, right? And so let's give ourselves a little more room with which to work here on router 1. And we'll go to the command line interface, and you can see the reason that we're already in global config is because remember, I changed the name inside the GUI, and so Packet Tracer was smart enough to say, oh, if he's changing the name in the GUI, then we need to change the name here. The switches should show, and they do, they show the same thing. So that's why we kind of already end up here in global config mode. So if I was to say do show IP interface brief, you can see that at 2911 we have 3 onboard gigabit Ethernet interfaces, gig 00, 01, and 02. Now these are all down, but we're going to be using gig 01. So let's go ahead and transition into gigabit Ethernet 01, and we know that our first interface is going to be 01.1, right? So typically you don't use VLAN 1, but we'll see what they're going to be using this for. Now remember, I need to start out with incap.1q, and I'm going to put 1, assuming that it is going to be VLAN 1. And let me, yeah, it looks like that is the case. And I'm just double checking here to see if that's the native VLAN or what they're using that VLAN for. It looks like the management VLAN. So I'll just go, we'll flow with it here. We're just going to say incap.1q1, and I'll use the IP address 192.168.1.1, and we've got /24s, right? So now I go into my next sub interface, gigabit Ethernet 01.10. incap.1q 10 for VLAN 10, IP address 192.168.10.1. And these are going to be our default gateways, right? And let's go into interface gigabit Ethernet 01.20, incap.1q20, and then IP address, and actually I can make this simple here. We'll just pull that back up and we'll change 10 to 20. All right, now that takes care of all of our sub-interfaces, but before we leave out of interface gigabit Ethernet 01, I want to say no shut, right? And you can see the parent interface is brought up and all the child or children sub-interfaces come up, or orange right here because spanning tree is now doing its thing, right? I believe that it might be dynamic auto on that port. And so it's trying to figure out, am I going to be a trunk? What am I going to do here? And then, no, I'm going to be a static access port because we haven't configured it as a trunk yet. So now when I say do show IP interface brief, you can see I've got my sub interfaces. Everything is good and ready to go. And we're all green on our port connections on that side. So that takes care of the sub interfaces. However, on the router, we're going to be simulating the internet or a host on the internet. And the way that we're going to do that is with a loopback interface. Now, remember, a loopback interface is a virtual software interface, right? It doesn't physically exist on the router. It exists in software, just like on the switch when we have the switch virtual interface, or the SVI. So we're not doing an SVI on the router. We're going to do a loopback address. So I'm going to say interface loopback 0, and I configure it just like I would any other interface, 209.165.200.225, and they give us the subnet mask. It's a /27, so it's a 255, 255, 255, 224. Again, we're borrowing 3 bits from the last octet. And again, the interface loopbacks are always up. As a habit, I always say no shut, right? But loopback interfaces are always up unless you shut them down, right? And that's one of the beauties of the loopback interface is it never goes down, right? The router would have to go down for the interface to go down, or you would have to manually shut that interface down. All right, so that takes care of the router configuration. Let me say write mem, and so on switch 1, right, we've got some configuring to do on switch 1. And again, I'm probably going out of order here. I'm just tackling this from the addressing table that shows at the very top of this Word document. And it's VLAN 1. It looks like we're going to be using interface VLAN 1. And the IP address is going to be 192.168. And let me double check that. Is that switch 1? Yeah, that's switch 1. And let me confirm on the diagram. Just real quickly, I want to double check here. Yeah, okay. Because we'll be in all kinds of trouble if that wasn't the case. So, and it's a /24. So VLAN 1 looks like it's going to be our management VLAN. Now, one of the things I see here is that we have to say IP, there's a default gateway. IP default gateway is going to be 192.168.1.1, right? And this is for management plane traffic. Traffic being generated on this or from this device. not transit traffic, which would be passing through the device, right? That is not what this is. Okay. And that takes care of switch 1. Now on switch 1, I'm going to go into interface, and actually let me do this. Let's take care of the VLAN 1 addressing piece first on the switches. And the switch virtual interface, we'll take care of that first. And we're going to say interface VLAN 1 IP address is going to be 192.168.1.12 for switch 2. And it is a /24. We'll say no shut. And I'm just looking at this IP default gateway. Oops. IP default gateway is 192.168.1.1. Again, remember, that is the sub interface on router 1 that we configured. And that is, again, for management plane traffic, right? It is not for transit traffic that is entering on one port and exiting another port. That's how we define transit traffic. Okay, so that's the VLAN 1 stuff. And now let's take care of the PCs here. Let's knock this out. And the PC addresses are going to be 192.168.10.3. And that is a 2/24. And our default gateway, 192.168.10.1, right? The interface on the subinterface on router 1. And so I should be able to right now come up here and say ping, and actually, no, I should not be able to do anything yet. And in fact, let me demonstrate that. So can I ping my default gateway, 192.168.10.1? And the answer is no, I cannot. So let me ask you, why can we not ping the subinterface? The subinterface on the router is up. The interface on the PC is up. What is the problem here? Yeah, we haven't done any VLAN configuration on the switch, and the trunk link between the switch and the router is not configured. So again, we've got to configure the switch first, and so we'll leave that where it's at. We'll bring the PC up here for PC2 or PCB, and let's say 192.168.20.3. And this is going to be a /24 and 192.168.20.1. Again, the interface, the subinterface on the router, we know we don't have connectivity, so we'll leave it there. Now we're going to do the switch port assignment. So now we're going to come back to the switch configuration. So let me slide this up here a little bit out of the way for switch 1. Now, on switch 1, we know that we're going to have 2 trunk links, right? That is going to be a trunk link. And this is, this is going to be a trunk link. So let's go ahead and knock that out. So we're going to get into interface fast Ethernet 01. This is the link between the switches. So I'm going to say switch port mode trunk. And you can see that it changed it down, then back up, right? We're changing the mode of the port. And let's take a look very quickly here. Do show interface fast Ethernet 01. And I'm sorry. Do show interface fast Ethernet 01 switch port, and the administrative mode is trunk and the operational mode is trunk. As I said, switch port mode trunk. Now, take a look here. The default is 802.1q. ISL is not even an option here. Okay, so I said switch port mode trunk. Now I'm going to say switch port no negotiate, because we don't need the dynamic trunking protocol to be running here. We have hard coded this port as a trunk port. Right, so that takes care of fast Ethernet 01. Now let's get into interface fast Ethernet 05. And this is the link to the router. And we're going to say switch port, and actually before I do this, let me say, do show interface fast Ethernet 05 switch port. Aha! And there is our friend Dynamic Auto from the Dynamic Trunking Protocol. But what is the operational mode? Yes, it is static access, because Dynamic Auto says, well, I'd like to be a trunk, but I'm only going to be a trunk if somebody on the other end of this link says, hey, let's be trunk links, right? And that's not going to happen, because the router is not saying, it's not running Dynamic Trunking Protocol number 1, but it's not saying, hey, I'm a trunk link, right? So it negotiated out and ended up, or couldn't negotiate a trunk link and ended up as a static access port, which is why VLAN 10 traffic from PCA, which we just tried to ping the subinterface on the router, is not going to go over that link. Right now, the only thing that would transit this link up to router 1 would be which VLAN? You've got it, VLAN 1, because that is the default right now. However, no PCs are in VLAN 1. All right, so what do we need to do? We need to say switch port mode trunk. I think I did this, or maybe I didn't. So switch port mode trunk, and there we go. So fast Ethernet 05 is now a trunk port, and we're going to say switch port no negotiate, right? Because we don't need it to negotiate to be a trunk port. It simply is. So now that that is a trunk link, let me say do show interface trunk. Always a very important command to run. So what is the problem right now? Or what would be the problem if I try to ping? So the ping's not going to work, but why? And I always like to come down here. We can see that, yeah, fast Ethernet 01 and fast Ethernet 05, these are trunks. The encapsulation, the trunking encapsulation is 802.1q. The native VLAN is 1, right? Now, again, in this activity, and I haven't scrolled down further, but in this activity, it looks like that's what we're going to be using. Remember, you should never, ever, ever be using VLAN 1 for anything. You should shut it down, disable it, right, and use other VLANs like 10 and 20. So our management VLAN, like in the Packet Tracer Activities 6412, the Skills Integration Challenge, 6338, the Inter-VLAN Routing Challenge, we were using, I think, 88 and 99 for native VLAN and management VLAN. That's what you should be doing. Your native VLAN should not be a VLAN that's being used for anything, right? And the management VLAN should not be the native VLAN. It should be any VLAN other than the native VLAN and VLAN 1. And it shouldn't be a VLAN that you're using for data traffic, right? Like a VLAN 10 is HR and VLAN 20 is your engineering department. So back to this last section of output here. What's the problem? VLANs in the spanning tree forwarding state. In other words, VLANs that are going to be allowed to go over that trunk link. Why is it only VLAN 1 right now? You've got it, because that's the only VLAN that exists on switch 1. And so since switch 1 only needs VLAN 10, and I'll say name, looks like students is what we're going to be using here, students, right? I have to create that VLAN. So now when I say do show interface trunk, right, you can see we've got VLAN 1 over both of those, and let me exit out here, do show VLAN brief. So we've got VLAN 10. However, none of the ports are in VLAN 10, but we know that this is fast Ethernet 06, and this is going to be in the student's VLAN. So let's get into interface fast Ethernet 06 and do our configuration here. So switch port mode access, switch port access VLAN 10. And I'm going to say spanning tree, port fast, and that light's going to go green. You see that? The light goes green immediately, right? Because that speeds up the process. I could also say a best practice spanning tree BPDU guard on an access port, right? And an access port is defined as a port where we have a server or an in-host, is to turn BPDU guard on to make sure no one unplugs this host and then plugs a switch in. It could cause a spanning tree loop. Okay, so now when I say do show interface trunk, aha, now we have interesting output here, right? So now not only is VLAN 1 allowed over these trunk links on these ports, but so is VLAN 10. So what's going to happen when I try to ping my default gateway? Yahtzee, right? Success. What's going to happen if I try to ping 20.3, the other PC? Is this going to work? So why is that not working? I'm trying to ping PC, I think I said PC3, I'm sorry, PCB, right? Why am I not able to ping PCB? Because my VLAN 10 is allowed to go over this trunk link right here. What's the problem? Yeah, it's not configured on this switch's side over here, on that side of the trunk link. So you may look at this and say, okay, well, hold on, Travis, all we need to do is to come over here and add VLAN 20 and say name faculty. And that'll fix the problem. And let me save my config real quick and say show interface trunk, right? So take a look at what's going on here. Is it allowed across the trunk links? VLAN 20. It's not. right? And the reason that it's not is we haven't configured it on the other end. There is no VLAN 20 on the other side here. So while it may be allowed and active in the management domain, right, and it may show up, when it shows up, I shouldn't say may show up, it does show up when I say show VLAN brief, there it is right there, but it only exists on one side of the trunk link here, right? It doesn't exist over on the other side, right? We haven't done anything yet when I say show interface trunk, and now it is there, right? So it is there, but what's the problem? If I try to ping, is that going to work? Because now it's there, right? And we had to wait for spanning tree to work itself out. Now it's there, but can I ping? No, I still can't ping. So we waited and we let the VLAN database update, and now the trunk ports are saying on this side, switch 1, that yeah, VLAN 20 traffic can go up here, and VLAN 20 traffic can go this way. And let me draw this out, I'm sorry. So VLAN 20 traffic can go this way, and VLAN 20 traffic can transit that. It can be forwarded over these trunk links. But what about that direction? No, we haven't configured that switch, and that's what we need to do right now. So let me clear the screen here, and let's get switch 2 up. And let's go from user exec into privilege exec into global config. And the first thing we're going to do is get an interface fast Ethernet 01. And we're going to say switch port mode trunk, and we're going to say switch port no negotiate. I'm going to create VLAN 20 on this switch. We're going to name it faculty. And I'm going to create VLAN 10. Whoops, sorry, VLAN 10, name students. Right, so both of those exist. So if I say do show interface trunk, we're going to wait for spanning tree here, right? We're going to wait to see what happens. Do we get VLAN 20? We need a port in VLAN 20 as well. And so we're going to make that happen right now. So interface fast Ethernet 018. And I'm going to say switch port mode access. Whoops, switch port mode access. Switch port access VLAN 20. And we're also going to say, whoops, not switch port, but spanning tree, port fast, and spanning tree, BPDU guard enable. So now let's say do show interface trunk. All right, looks much better. So PCA trying to ping PCB. What do you think? Maybe. We'll give it a second here, and there it is. Now, I like the way that they laid this activity out, because let me ask you, is the packet flow on this ping right here that we just ran right here, is PCA's packet flow going this direction with the red line, or is PCA's packet flow going this direction following the green line? Because remember, we have a trunk link here, right? So VLAN 10 and VLAN 20 traffic can transit this trunk link. Is that what is happening? And the answer is no. The red line is not what is going on here. Remember, let me pick we'll do blue here. So what's happening is we say ping, and I gave the IP. And on PCA, it looks into its network table and says, do I have a network network entry, not injury, a network entry for 192.168.20.3? Is there a network statement that reflects this network? And the answer is no, there is not. And so the first request timeout is waiting for an ARP reply to come back. So PCA says, all right, well, I need to send this to my configured default gateway, which I did in one of the earlier steps when we configured the PC. So PCA says, okay, I don't have an entry for this, so I am going to send this to my default gateway. And my default gateway is configured as the sub-interface gig 01.10. which was 192.168.10.1. And that's here on the router. And so that traffic comes up into the switch port here, goes over the trunk link with VLAN tag 802.1q tag 10, and shows up on that physical interface right there. Now, that physical interface receives this traffic and says, hey, I have multiple sub-interfaces configured here. How do I differentiate? I look at the 802.1q tag. And it just so happens that this is tagged with VLAN 10. It says, yep, I'm going to pass you off to gig 01.10 because it's on this sub-interface where I see the incap .1q 10 configuration. So the router passes it off to the sub-interface. The router sub-interface then says, okay, let me peek into the IP header and look at the source and, more importantly, the destination layer 3 information. And now the router, right, because this is a router at layer 3, and that's where the router operates, is layer 3. That's a layer 2 switch, and we forwarded things based on MAC addresses. And layer 3 is our router. And it says, let me peek in here and see, what is the destination address? Well, it's .20.3. And remember, the router now says, let me look into my RIB, my routing information database, which is what we see when we run show IP route. And the router says, do I have an entry that this address would fall into, the 192.168.20.3? And it just so happens that it has a sub-interface that is .20.1/24, meaning that, yes, this would fall into that range. And that is how the router makes its forwarding decision and says, yep, you're going to go out my sub-interface over this trunk link down here, because that trunk link has access and visibility into the VLAN 20, where it might have to ARP out to figure out, give me the MAC address for this. And to see that that is where it's going to get forwarded, the switch receives it, sends it over the trunk link, because that is where the MAC address table is telling it to be sent. It hits switch 2, and switch 2 says, yep, because we're now at layer 2. We're not dealing with layer 3 anymore. We're dealing with layer 2. And switch 2 says, hey, the MAC address that you're looking for is on that port right there. And it forwards it out at layer 2 to the PC. The PC gets it, and it peels back layer 1, right? The bits just coming in, layer 1. And let me draw the little packet out right here. So it looks in layer 1, and then it looks in layer 2 at the source and destination MAC address and says, is that destination MAC address me? And if it is yes, it peels back the layer 2 and looks in at layer 3 and sees the destination IP as itself. And then it says, hey, all right, let's process layer 4 and then our application layers 5 through 7, right? So that is how it is all happening with our Inter-VLAN routing. And now everything is going to work. And give me a second here. I'm going to scroll down. I did this off of the addressing table. I haven't actually been following what they've been asking for. And let me make sure. Yeah, they had you do some, no IP domain lookup, service password encryption, and that's fine. And they basically give it, you can copy and paste that in. We configured the VLANs. We talked about the VLANs being assigned. We looked at the Inter-VLAN routing. That got done. Okay, they had us do some, testing. And so let's see. The number one, or the best test is going to be, can I ping that loopback address, 209.165.200.225, right? Kind of simulating, hey, can I get to the internet and get back? And yes, we can. And remember, that loopback address is just a software address and this is how you'll see loopbacks, right? It'll be a line and then this little, hey, this is a LAN segment of some kind, loopback LO0. Right, so we can do it there. Can I do it from PCB? And we haven't tried from PCB. We haven't tried anything here from PCB. Can I ping 209.165.200.225? Absolutely. And we'll let this finish. Can I ping PCA 192.168.10.3? And this is going to work, right? Because we've got everything set up. We're forwarding. Everything is working as it should. All right, well, that is going to conclude lab, right? Not packet tracer. We did it in packet tracer, but again, this is if you had an in-class lab, this is one of the activities you'd be doing. So lab 6.3.3.7, where we are taking our final look at 802.1q trunk-based Inter-VLAN routing. All right, guys, thanks so much for watching. And now we're going to be moving on to Chapter 7 and getting into some deep dive conversations on access control lists. All right, enjoy your snow day. I will talk with you guys soon.